ನಾವು ವಿಶ್ವ ಕನ್ನಡಿಗರು.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ನಾವಿಕ ಬಂಧುಗಳಿಗೆಲ್ಲ ಇವತ್ತಿನ ದಿವಸ ನಮ್ಮೊಂದಿಗೆ ಡಾಕ್ಟರ್ ಕೆ.ವಿ. ಸುಂದರೇಶ್ ಅವರು ಇನ್ಫೆಕ್ಷಸ್ ಡಿಸೀಸ್ ಸ್ಪೆಷಲಿಸ್ಟು. ಬೇಸಿಕಲಿ ಇನ್ಫೆಕ್ಷಸ್ ಡಿಸೀಸ್ ಅಂತಂದ್ರೆ ಈ ಕೊರೋನಾ ವೈರಸ್ ಕೇಸಸ್ ಹಾಸ್ಪಿಟಲ್ ಅಡ್ಮಿಟ್ ಆದಾಗ ಸಾಧಾರಣ ಒಂದು ಇನ್ಫೆಕ್ಷಸ್ ಡಿಸೀಸ್ ಅವ್ರನ್ನ ಕನ್ಸಲ್ಟ್ ಮಾಡೋದು ಒಂದು ಪರಿಪಾಠ. ಇವರು ಈಗ ಒಂದು ಸುಮಾರು 40 ವರ್ಷದಿಂದ ಹಿ ಈಸ್ ಪ್ರಾಕ್ಟಿಸಿಂಗ್ ಇನ್ಫೆಕ್ಷಸ್ ಡಿಸೀಸ್. ನನ್ನ ಪ್ರಕಾರ ಈಸ್ ಒನ್ ಆಫ್ ದ ಸೀನಿಯರ್ ಮೋಸ್ಟ್ ಇನ್ಫೆಕ್ಷಸ್ ಡಿಸೀಸ್ ಸ್ಪೆಷಲಿಸ್ಟ್ ಇನ್ ಅಮೆರಿಕಾ. ಈಗಾಗಲೇ ಅವರು ಇದರ ಪ್ಯಾಂಡಮಿಕ್ ಹಾಗೂ ಈವನ್ ಸಾರ್ಸ್ ಮರ್ಸ್ ಟೈಮಲ್ಲಿ ಕೂಡ ಅವರು ತಮ್ಮ ಒಂದು ಸಹಕಾರವನ್ನು ತಮ್ಮ ಒಂದು ಸ್ಪೆಷಲೈಸೇಷನ್ ನಲ್ಲಿ ಇರ್ತಕ್ಕಂಥದನ್ನ ಜನಗಳಿಗೆ ಹೇಳಿಕೊಟ್ಟಿದ್ದಾರೆ. He is a very good teacher and he is a constant speaker on all the topics about infectious disease. ನಾವು ಅವ್ರನ್ನ ಕೇಳ್ಕೊಂಡ್ವಿ. ಈಗ ಅವರು ಬಹಳ ಬ್ಯುಸಿ ಆಗಿರ್ತಂತ ಟೈಮು. he is seeing lot of patients with corona virus. ಈ ಒಂದು ಸಂದರ್ಭದಲ್ಲಿ ಕೂಡ ಅವರು ಬಿಡುವು ಮಾಡಿಕೊಂಡು ಇವತ್ತು ನಾವಿಕಾಗಿ ಪ್ರೆಸೆಂಟೇಷನ್ ಕೊಡಬೇಕು ಅಂತ ಕೇಳ್ಕೊಂಡು ಬಂದಿರೋದಕ್ಕೆ ಅವ್ರಿಗೆ ಧನ್ಯವಾದಗಳನ್ನ ಹೇಳ್ತಾ ಅವ್ರನ್ನ ವೆಲ್ಕಮ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಥ್ಯಾಂಕ್ ಯು.
ಬಹಳ ಥ್ಯಾಂಕ್ಸ್ ಕೇಶವ್ ಬಾಬು ಅವರೇ, ತುಂಬಾ ಥ್ಯಾಂಕ್ಸ್. ಡಾಕ್ಟರ್ ಸುಂದರೇಶ್ ಅವರೇ, ಇವಾಗ ನಿಮ್ದು ಸ್ಟೇಜ್.
ಹಲೋ, ನಮಸ್ಕಾರ ಎಲ್ಲರಿಗೂ. ಫ್ಲಾರಿಡಾದಿಂದ ವೆಲ್ಕಮ್ ಫ್ರಮ್ ದ Navika and from myself and my family. Also, I like to thank Valisha Shastri, Keshu Babu, and also Renuka and all the organizers to giving me this opportunity to talk about coronavirus. Okay. Yeah, let me see. I'm having some problem with the technical. Okay, there it is. Okay, thank you. Today I'm going to talk a little bit about the pandemic, how it's spreading, and some clinical pictures and infection control measures and how to keep yourself safe. The virus, the virus is called a coronavirus, as you're all well familiar. It's a very common virus. Some of you may not realize it. It's a very common virus. When you get a cold, for example, almost 10 to 20% of that caused by coronavirus. And we never paid attention to it until now, but now it has become a big issue, and it has become a pandemic only because it has a minor mutation. So it's what we call in medical terms as a zoonosis. That means, it's an infection typically in animals, and it jumps to humans. That's what a zoonosis is. And the bats, typically, they carry this particular type of coronavirus. And of course, there are other species that carry the coronavirus, sometimes birds, sometimes other mammals. But the current virus that we are talking about, it's a bat virus. And there were two other viruses that caused havoc back in 2002, for example. This one, you probably remember, SARS-1. And that jumped from bats to a mammal called like a cat. It's a civet cat. And then it came to humans. And the second one in 2013 and 14 jumped to camels, and from camels to humans. This particular pandemic, it's called COVID-19. We don't know how it jumped to humans. Maybe it jumped directly from bats, or maybe it came through another mammal. We don't know. But once it came to the mammals, now it has become like a human to human. So it's going from one person to the next person to the next. And also in the hospitals, it's going from the patients to the doctors, nurses. So that's what a pandemic is. So it has developed the capacity to rapidly go from one person to another person. You all heard of this joke, Okay, so the epidemic started in Wuhan, as you are well familiar. They call it a wet market. So this probably started way back in November, or at least December, that we know of. And since then, it has rapidly spread all over the world. So this particular graph I want to bring your attention. It's not a complicated graph. So this is telling you how fast it's spreading after like 100 days of the epidemic. And so the blue graph here belongs to SARS-1. But look at the graph, it's going up so slowly here, right? And then it petered off after, say, 6 months or so. But the current virus, look at that. This caught my attention even back in January, even before all the pandemic was evolving. It is taking off like a rocket. That's the big difference between the old one and this one. This is an extremely contagious virus, and it's going off very fast. And what started in China, killing hundreds of people and infecting at least 100,000, maybe close to 500,000 people. Now it's become a pandemic. I know some of you may not be medical people, but still I want to simplify this pandemic potential for this. There is an infectivity rate called R naught value. We call it R naught. So for this particular virus, it's about probably 2 to 2.5. So let me explain in simple terms what R naught means. Okay, if one person gets infected, that particular person will infect 2 other people or 3 other people. So that person will infect another 2 to 3 people. That's what it is. So that's an important number, R naught. So that's why I'm mentioning it here. And the second parameter is called a case fatality rate. It's approximately like 2.2%, but here in America, it's been around 3 to 3.5% so far. And in Italy, for example, it was even higher, 4, 5, 6, 7, maybe even 10%. And Iran, it was higher. And it varies from country to country. And the incubation period is about 3 to 4 to 5, 6 days. It can vary from 2 to 14 days. And as I told you, R naught, it's a capacity, how fast it can spread. 2 people give it to 4, 4 people to 8, 8 to 16, so on and so forth. And this particular slide shows you how much it's able to spread. For example, if a person infected in a subway, he can infect somebody 6 feet around him. And whereas measles is even worse. It can infect up to 100 feet around the person. Whereas influenza, maybe 2 feet. So that gives you a perspective how bad or how worse it can be. And how bad the epidemic will get, you are already witnessed that. This was already a month old. Since then, it has become a pandemic. You saw that it spread very rapidly in Italy, and slowing down Italy, fortunately, but still, unfortunately, they had a very miserable March and part of April, and it's starting to slow down. It's still going on. A lot of people getting infected and dying, and parts of the country still locked down. And you all heard about that Diamond Princess cruise, and almost 1,000 people got infected there. And that was a perfect breeding ground for the virus, and also for the epidemiologist, also a rare opportunity to study the epidemic. So they can study how many, because it's a controlled environment, they can study how many people got sick, how many did not get sick, how many died, and so on and so forth. So why the epidemic spreading so fast? In one simple word, it's the airplanes. The planes are literally spreading the virus. It takes less than a day for somebody from China to come to America, right? So for the virus, it takes the same time to jump from China to America, America to Mexico, Italy to India. So the whole world is connected so fast. So what took like 6 months for a Spanish flu to spread around the world is taking 6 days now. And the New York, as you know, has become the epicenter of this epicenter of epidemic here in the country, as you are all familiar. And what I'm showing you here in this graph, look at that, the New York, it's taking off very fast. I think if you can read the different states, you can learn some lessons here. Look at California, it's going a little bit slower. Washington's state also slower. Some of the Midwestern states are even slower here, like Iowa and all that. And Texas, Michigan, they're all going at different paces. Louisiana going also fast. So why I'm saying that is each state is almost like its own mini epidemic there. And we here in Florida, we have not had a major outbreak yet. Hopefully not like at New York, but we don't know. Yeah, this is a cartoon of our governor, DeSantis. Like you probably saw the Jaws movie, Jaws 1 and Jaws 2, like it's the mayor of Amityville kind of sitting there, like a lifeguard chair. Unfortunately, easy for us to criticize the governors, but they have a tough job of balancing a business versus a bad infection. But that's the dilemma we are facing right now. And you may have heard people in Florida that Jacksonville Beach already open. Hopefully that won't open up the epidemic again. And what's the future of the epidemic? Nobody knows for sure, but the most prestigious model is called IHME. That's from the Washington state modelers. And they are projecting, of course, this is a mathematical model, and they have been wrong many times. And I shouldn't say wrong, they have revised their models so many times. And they have revised it fourth time last week. So according to their projection, right now, New York and many states are on the downward trend. And some states like Florida, we are still in the upward trend, maybe another 2-3 weeks. And we don't know what is going to happen in the fall season. Most people are expecting, okay, when the summer comes, when the fall and the summer heat, it will slow down, but we don't know what will happen in, say, October or November. It might get worse again. Hopefully we are prepared to deal with it by then. According to the models, you can see 60,000 people are expected to die from this by August. Again, hopefully it will be less than that, we don't know. Okay, so you have seen this map many times, John Hopkins map of the epidemic. I just want to show you that the epidemic is enormously different. Say, for example, New York, very bad. And East Coast is fairly bad, but the mid states and Midwestern states are not too bad. And California also, you can see, it's kind of medium. Of course, the epicenter is still northeast. New York and New York, Connecticut, and that area. In India, I want to just briefly touch on that. So far, this was yesterday, actually day before yesterday, 12,700 reported cases, confirmed cases, I should say, and 423 deaths. And you should realize this is a way underestimation of the real numbers. So if they are saying 12,000 confirmed patients, you could probably multiply that by at least a factor of 10, 100,000, I would say. And how bad it's going to get, that's anybody's guess. The only thing that people are saying, okay, it's a summer country, a lot of heat might help a little bit. But there's so much of crowding, population, poverty, it's a disaster waiting to happen. And as they say, it's a billion person question. So I'm going to briefly talk about some of the patients, how they, you hear about the epidemic, how do the patients behave? Most patients have fever, 99% as you can see, and they also have cough. The cough is extremely annoying. They constantly cough. If they start talking, they start coughing. I'm not talking of every patient, the ones that we see in the hospital. And SOB is shortness of breath. That's the short term for us. Most of them have shortness of breath. And GI symptoms like diarrhea, vomiting, maybe 8%, 10%. And I want to show you this part of the slide here. 81% have mild disease. That means, most patients don't have too much problem. And in fact, 20 to 30% may not even know that they have the infection. And they don't even know they have infection. Some of them, they have some mild cold symptoms. But about 15% up to 20% can have severe symptoms and they need to go to the hospital. And 5% end up in ICU. And about 2-3% die from the disease. And that's the spectrum we see. And I just want to share a patient that we had last week. I probably have seen about 20, 25 patients so far. And most of them, knock on wood, have been doing well, except 3 patients, they're still in the ICU on the ventilator. But majority of the patients, they seem to be doing well and going home. This is a 35-year-old man who was otherwise healthy, works in Tampa Airport, and comes to the emergency room with 5 days history of cough and fever and shortness of breath, basically. He also reports one of his coworkers, he was sick. And I won't go into all the medical details, except he had a very low oxygen, and X-ray showed, like a pneumonia in the basis. And as usual, he was started on hydroxychloroquine and azithromycin, but he continues to do poorly even on this and had to be put on oxygen. And after struggling for about 2 weeks or so, finally he left home a couple of days ago. He's doing well now. And this particular slide, I want to show it to for medical people in the audience, but also for everybody else. Nosocomial 41%. So that means there's a very high chance the infection spreading from patient to patient in the hospital, patient to the nurse and the doctors. So also same thing applies to family situation. Family members can get infected very easily. This is the CAT scan findings in a patient with COVID pneumonia. The white stuff is the pneumonia part and the black stuff is the oxygenation part. So you can see a lot of white stuff here. And that middle part is the heart. And older people, as you can imagine, they do very poorly. And most of the people who die, they're older people, about 80. But that doesn't mean only older people get sick. Anybody can get sick and anybody can die. And, I heard in New York City, 15-year-old, 20-year-old, 30-year-olds have died. So anybody can die, previously healthy can die. But typically, majority of the people, 80-year-old, for us in Florida, we have a lot of nursing home patients and they can be having devastating results. And this looks like a little technical slide, but I'll simplify this and tell you about how the virus is killing people. Okay, so normally the cold virus is mostly attacking the nose, right? And the throat maybe. But somehow, with some minor mutation, it's able to go all the way to the bottom of the lungs here. And here we can see the alveoli. So it's starting to attack a cell called ACE2 cell. So if this is an ACE2 cell, if this is a virus, it's going and docking like that. And that's what it's doing. And it's exactly able to dock onto the ACE2 receptor cell and then starts hijacking the immune system here. And it's also hijacking the genetic system and taking over the genetic system and start making lots of baby virus here, you can see. So this is the ACE2 cell, and this is the SARS virus coming in there. and it docks in here and it gets into the cell and it takes over the whole genetic system here. And pretty soon it's making lots of baby cells and spitting it out, thousands and millions. And that is facilitated by here you can see the spike protein. The spike protein is latching onto the ACE2 receptor. And that's what you call, you may have heard of the term cytokine storm. And when it's taking over the immune system, it's making a lot of cytokines, and that's destroying the lung tissue by itself. And you can see on the left half is the normal alveolar cell, not the cell, alveolar structure, and the right side is the infected and injured alveoli. And all these interleukins, 1, 2, 3, 4, 5, 6, the medical people will understand that. And that's what's causing the problem with oxygenation here. And so the oxygen comes here from the air, and a normal healthy lung, it can exchange it to the red cells. But here, as you can see, right side here, it's all so much of inflammation, and oxygen cannot exchange. And that's what's causing the pneumonia, and patients are dying. If a lot of alveoli are infected like that, lungs cannot oxygenate, basically. Okay, so the rapid test, I'm going to take another 10 minutes, maybe 5 to 10 minutes. The rapid test, it's called a reverse transcriptase PCR, and it's a very easy test, but it's not, unfortunately, not easily available to us, and more and more available. It's only a 15-minute test now, but we are still struggling to get it done. It's taken, for example, for us about 1 day, 2 days to get the test done, get results back. But the actual test takes only 15 minutes. So there is also an antibody test, which tells you, okay, you are immune to it. It's already available, but again, it's not available to us. It's available in the country. Hopefully it will be available to everybody soon. Okay, I'm going to talk a bit about treatment. Unfortunately, no good treatment available. Everybody has heard of chloroquine and hydroxychloroquine, and that's probably what we are using mostly, hydroxychloroquine and azithromycin. How do we use it? We use it for people who are really sick in a hospital. I would not recommend for prophylaxis, although in India, the government has put out a protocol, like to take it to 400 milligrams twice a day, and then 400 once a week. But I would not recommend that because the data is really, really poor. I think the one exciting drug is called the remdesivir. A lot of buzz about it. Still double-blind studies are not open, but it looks like a lot of promise to that. It's an injection, 10-day injection in the hospital. And we are also using drugs called interleukin-6 inhibitors, Actemra, which made by the Roche company and other companies, and they calm down the inflammation. And the vaccine, that's the main thing that everybody's hoping on. At least 37 vaccines are in trial, so hopefully we'll have something by next year. Unfortunately, it won't be ready for this epidemic, this pandemic. So hopefully by end of the year, we will have something, everybody's hoping. And so it's a race against time, basically. The longer it takes, the more people die. So you all heard of this flattening of the curve. So what it means, you probably know already. So instead of a big spike like this, without any protection and everything, it will overload the system and a lot of people die. Whereas if you can mitigate, slow it down, so with the distancing, social distancing, with school closures, so on and so forth, you're not eliminating the infection, but you're just prolonging it so that we can handle it. And this is a more sophisticated way of same epidemic here, flattening the curve, you can see. So the good old way of namaste in India, I think that we should use that, and so that we can avoid a body contact. And it also has religious significance, and I think it's a good thing. And you all know about this soap. Soap is very good because it is destroying the lipid layer of the virus. And the T zone is called a T zone: eyes, nose, mouth. So make sure that you're protecting it, that area. And diet is very important. Zinc, a lot of the fresh vegetables, avocado, nuts, all of that. Good sleep is, immune system modulates. And physical activity, healthy grains and vegetables, and not processed food, basically. We are all a global village, and so what's happening is that we are we become one community. So I'm just going to end this by a small mantra, and I will open up for questions if there's any time. Om Namo Bhagavate Vasudevaya Dhanvantraye Amrita Kalasha Hastaya Sarvamaya Vinashaya Trailokyanataya Shri Mahavishnuve Namaha.
ವಲೀಶ್ ಅವರೇ, ನಾನು ಸುಂದರೇಶ್ ಅವ್ರನ್ನ ಚಾಟ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ದೀನಿ. He has already taken down all the questions. ಸುಂದರೇಶ್, ನೀವು ನೋಡ್ಕೊಂಡಿದ್ದೀರಲ್ಲ questions ಎಲ್ಲ?
Yes, ಹೌದು.
Yeah, quick ಆಗಿ ನೀವು within about a couple of minutes, if you can answer those questions, then ನಾವು ಬೇರೆ ಮುಂದಿನ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ move ಆಗೋಣ.
Okay, so let me take one or two questions in a few minutes. Okay, the first one about the antibody testing, Sandy, but she had asked. I think it's a very good, important question there. That the role of antibody is probably going to be very important in the next phase of that epidemic control. So what we can use it to see how many people are immune, so that suppose in a medical field, if they do my antibody test, I'm positive, that means I'll be comfortable taking care of sick people, even though I may still use the PPE. I still be comfortable in taking care of those patients. That's one major advantage. And the second advantage of antibody testing is to see how many are already immune, so they can open up the society. It's a lockdown is terrible for everybody. So that's a very important tool for opening up the society. Those are the two important things. And of course, for research and collecting plasma for donors to treat other patients, that would be useful too. So those are some of the important uses of antibody. But it's still not available widely. That's the problem. Hopefully, it will be available. So can I take one more question? Lakshmi Prasad Padumane, he has asked about myocarditis. I have seen one patient with myocarditis. The coronavirus, COVID-19, causes multiple organ involvement, not just the lungs. We don't know what's causing that. Is it a direct attacking on the muscle of the heart muscle? Probably not. It's more cytokine mediated. Cardiomyopathies, strokes, conjunctivitis, lack of taste, so many other things which we didn't have time to go into. But there are so many syndromes, and we are learning as we are going by. And the myocarditis can also abruptly kill people too. So far, in New York, they have seen patients recovering, abruptly dying. And so that one theory is that, okay, they may have myocarditis. Do you have time for a third question? Or
ಸುಂದರೇಶ್ ಅವರು ಈಗ ಜನರಲ್ ಪಬ್ಲಿಕ್ ಹೇಳಿದ್ದು ಮಯೋಕಾರ್ಡೈಟಿಸ್ ಅಂದ್ರೆ ಇದು ಇನ್ಫ್ಲಮೇಷನ್ ಆಫ್ ದ ಹಾರ್ಟ್ ಅಂತ. ಸೊ ಅದು ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದ್ರು, ಹಾರ್ಟ್ ಅನ್ನ ಮಯೋಕಾರ್ಡೈಟಿಸ್ ಇನ್ವಾಲ್ವ್ ಆಗ್ಬೋದು ಅಂತ ಕೇಳಿದ್ರು. ಅದಕ್ಕೆ ಸುಂದರೇಶ್ ಅವರು ಒಂದು ಪೇಷಂಟ್ ನೋಡಿದ್ದಾರೆ ಅದನ್ನ ಅಂತ ಅವರು ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. It can involve the heart. There have been 7% cases of reported myocarditis, and it can also cause a sudden death. ಅದನ್ನ ಸುಂದರೇಶ್ ಅವರು ಆನ್ಸರ್ ಮಾಡಿದ್ರು. ಇನ್ನೊಂದು ಕ್ವಶನ್ ಸುಂದರೇಶ್ ಅವ್ರಿಗೆ ಓ ಪಾಸಿಟಿವ್ ಗ್ರೂಪ್ ನವರು ಇಮ್ಯೂನ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಅದನ್ನ ಕೇಳಿದವರು ವಿಕ್ರಮ್ ಪೋದ್ದಾರ್ ಅವರು.
That question is I don't think it's so black and white. There is some immunity to certain blood groups. Immunity means that it's not like they won't get it. It's just that they may get a less severe disease and less percentage-wise less. So nobody knows what it means. Is it just a fluke that they're not seeing less infection, or is there something else going on? It's still a big question mark. But you know, time has to decide. You know, a lot of things I would not pay too much attention at this time. Like, you know, 2 months ago they would say, okay, only Chinese people would get infected, nobody else. That was a big bunk. Same Indians don't get it, so that was false also. So a lot of this information I would take it with a pinch of salt at this time, because the mechanisms are still not clear. So I would not be too you know, aggressively thinking that's correct. But you know, yeah, that's a good thought though. Research, good thought for research.
ಸುಂದರೇಶ್ ಅವರೇ, ಬಸವರಾಜ್ ಬೆಂಕಿ ಅವ್ರು ಕೇಳ್ತಾರೆ, ಮಕ್ಕಳು ಕೂಡ ಲೋ ಇಮ್ಯುನಿಟಿ ಇರುತ್ತಲ್ಲ, ಸೀನಿಯರ್ಸ್ ಬರುತ್ತಲ್ಲ, ಮಕ್ಕಳಿಗೆ ಯಾಕೆ ಅಷ್ಟು ಸಿವಿಯರ್ ಆಗಿ ಬರೋದಿಲ್ಲ ಅಂತ ಕೇಳ್ತಾರೆ.
Yeah, that's a very frequently asked important question. The older it is, the seem to be higher is the mortality, worse is the disease. It's still not very clear. One explanation is, okay, the children get a lot of frequent coronavirus infections in daycare centers and, you know, being with other children, maybe they have immunity. Other thinking is, okay, their cytokine storm is able to handle it better. But it's very clear that children are less affected. You know, very few children have died. But children have died rarely, unfortunately. But it's extremely rare, and they are very immune to infection. That's true. A lot of it is still in research stages.
ಇನ್ನೊಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ, ಹೌ ರಿಲಿಯಬಲ್ ಇಸ್ ವೆಬ್ಸೈಟ್ worldometers.info, ವರ್ಲ್ಡೋಮೀಟರ್ ವೆಬ್ಸೈಟ್.
They are reliable if you know how to use it. Even the John Hopkins map, I wouldn't say it's not reliable or reliable, but you have to know how to use it. These are all just numbers accumulated from all reliable sources. That much I can tell you. Worldometer and also the WHO numbers, John Hopkins, they're all extremely reliable, but they underestimate the number of people. So don't think, okay, if they say 2.2 million people infected in John Hopkins, probably you can easily say 5 million people are infected or even more. So you have to know the perspective, but it doesn't make it any less accurate. It's just extremely accurate site, but they have limitations. You know, a lot of them are not even tested. So how can they report? A lot of them, you know, even China, for example, I wouldn't say they're unreliable, but they're 4 times they revise their numbers. One reason is, okay, people who died at home, they didn't report before. Now they're reporting. So people who had only X-ray findings, they did not include that. Now they're including. So you change the criteria, the death rate changes. So it's really not, you know, fair to say it's reliable or not reliable. But of course, you have to make sure that the people who are posting on it are reliable. So definitely John Hopkins, Worldometer, WHO, CDC, they're extremely reliable. But you have to know how to use it though.
ಡಾಕ್ಟರ್ ಸಂದೇಶ್ ಅವರೇ, ರೇಣುಕಾರಾಧ್ಯ ಅವರು ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ವೈ ರೆಮಿಡಿಸಿವಿರ್ ಇಸ್ ನಾಟ್ ಯೂಸ್ ವೈಡ್ಲಿ ಇನ್ ಪೇಷಂಟ್ಸ್ ವೆನ್ ಯು ಹ್ಯಾವ್ ದಿ ಇನಿಷಿಯಲ್ ರಿಪೋರ್ಟ್ಸ್ ದಟ್ಸ್ ಹೆಲ್ಪಿಂಗ್.
Yeah, the problem is multiple problems, Renuka, and also everybody else. The reason is, first of all, it's a very short supply of the drug. It was an Ebola drug developed for Ebola, but it didn't do that well for Ebola. But they found in test tubes it's an extremely good drug for the COVID-19. So they started using it. And so they have to start manufacturing. You know, this is a new drug, not even approved. It's approved only for emergency use for Ebola, but now FDA has given an emergency use, allowing us to use for an emergency. But we tried to use it for 3 patients and they were not able to give it to us. So if the patient is a child or a pregnant mother, they give it. Or if they're in a study group, like half patient get placebo, half patient get the drug. So they can use it. If you just want to use it for, any other patient that they are giving, it's very hard to get it. It's a lot of supply issues and research issues, but it seems like a good drug though. And I think it's really a good good drug. We don't know. We still don't have a double-blind study to say that it is definitely works, but everybody thinks it works.
ರೆಮ್ಡಿಸಿವಿರ್ದು 2 ರಿಪೋರ್ಟ್ ಬಂದಿದೆ ಈಗ. ಒಂದಾಗಲೇ ಶಿಕಾಗೋಯಿಂದ ಒಂದು ರಿಪೋರ್ಟ್ ಲೀಕ್ ಆಗಿದೆ. 113 ಪೇಷಂಟ್ಸ್ ಅಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 111 ಜನ ರಿಕವರ್ ಆಗಿದ್ದಾರೆ ಅಂತ ಹೇಳಿ. ಇನ್ನೊಂದು ರಿಪೋರ್ಟ್ ನ್ಯೂ ಇಂಗ್ಲೆಂಡ್ ಜರ್ನಲ್ ಮೆಡಿಸಿನ್ ಅಲ್ಲಿ ಪಬ್ಲಿಷ್ ಆಗಿದೆ. ಅವರು ಫೈನಲ್ ರಿಪೋರ್ಟ್ ಈಗ 400 ಪೇಷಂಟ್ಸ್ ಲಾಕ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರಂತೆ. ಅದರ ರಿಪೋರ್ಟ್ ನೆಕ್ಸ್ಟ್ ಈ ಒಂದು ವಾರದಲ್ಲಿ ಬರಬಹುದು ಅಂತ ಒಂದು ಸೂಚನೆ ಇದೆ. ಸೊ ಜನ ಅದನ್ನ ರೆಮ್ಡಿಸಿವಿರ್ ಅಂತ ಹಾಕಿ ಆ ರಿಪೋರ್ಟ್ ನ ಫಾಲೋ ಮಾಡ್ತಾ ಇದ್ರೆ ಅದ್ರ ಬಗ್ಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ಗೊತ್ತಾಗುತ್ತೆ. ಇದು ಒಂದು ಕಡೆ ಕ್ವೆಶ್ಚನ್ ಸುಂದರೇಶ್ ಅವರಿಗೆ. BCG ವ್ಯಾಕ್ಸಿನೇಷನ್ ಯಾವ ರೀತಿಯಾದಂತ ಒಂದು ಇಮ್ಯುನಿಟಿ ಕೊಡುತ್ತೆ COVID-19?
Hello, Ravindra. Namaskara. The BCG, it seems very exciting, like a concept. It's not clear how it works, but it's not even clear it works to prevent it. But a lot of people are saying, okay, BCG is a very common vaccination in India, for example, and South Asia, Southeast Asia, and Eastern Europe. They use quite extensively for preventing tuberculosis. It does a very poor job of preventing tuberculosis, but it does some job of preventing TB, meningitis maybe. So there is some theory that, okay, that may stimulate the monocytes. I don't want to get too technical. There are a lot of non-medical people, but the innate immunity may be stimulated. So their immune system is going to be more robust, hopefully robust. We don't know that true. So that's one of the working hypotheses. But it is true that BCG, people who have BCG, seen BCG, the areas have less COVID. But it may just be also just a coincidence too. It's not a direct research. It's more like an observation based on the epidemiology of the disease. So
ಥ್ಯಾಂಕ್ಸ್ ಸುಂದರೇಶ್ ಅವರೇ.